Quantum computing. You hear about it all the time, right? It's this technology that promises to completely change, well, everything. But it's also wrapped up in so much hype. So what's real and what's still just science fiction? Let's dig in.
And that really brings us to the biggest question of all. With all the money, all the research, all the brilliant minds working on this, why don't we have a truly useful quantum computer sitting in a lab somewhere yet? That's what we're going to break down. But first, let's get on the hype train. Before we get into the problems, we have to understand why everyone is so excited. What is the incredible promise of quantum computing?
I mean, we are talking about world-changing stuff. Things like designing new drugs, molecule by molecule, to cure diseases. Or creating batteries so efficient they could transform our energy grid. Or what about optimizing financial markets to prevent crashes? And that's not all. Imagine next-level AI, logistics so perfect you never sit in a traffic jam again, and, this is the scary one, the power to break almost all the encryption that keeps our digital world secure. That's the promise. It's huge.
Okay, so what's the secret sauce here? How does this even work? Well, it all comes down to using the totally weird and frankly wonderful rules of quantum mechanics.
Everything starts with a qubit. You know how a normal computer uses bits, right? A bit is like a light switch. It's either off or on, a 0 or a 1. Simple. A quantum computer uses a qubit. And a qubit, well, it's a whole different animal. It's the absolute foundation of all of this.
And this is where your brain starts to melt a little bit. It's because of a principle called superposition. A qubit can be a 0, it can be a 1, or it can be a combination of both at the exact same time. The classic analogy is a spinning coin. While it's in the air, it's not heads or tails, it's kind of both. Only when you measure it, when you stop it, does it pick a side.
And if you thought that was strange, hang on. There's also entanglement. This is where you can link two qubits together so their fates are completely intertwined. If you measure one and find out it's a 0, you instantly know the other one is a 1, even if it's on the other side of the galaxy.
This idea was so bizarre, so counterintuitive, that Albert Einstein himself just couldn't fully get on board with it. He famously called it spooky action at a distance. And it's that very spookiness, that complete break from how we see the world, that gives a quantum computer its almost magical potential.
So let's just boil it down. A classical bit can only be a 0 or a 1. That's it. But a qubit, because of superposition and entanglement, can explore a massive number of possibilities all at once. That is the fundamental reason a quantum computer could be so incredibly powerful.
Okay, so we have this amazing promise and this mind-bending theory. Where's the disconnect? Why don't we have these things yet? Well, this is where we get off the hype train and run smack into a brick wall called reality. The engineering challenges here are just monumental.
To really understand the problem, just look at the error rates. Your laptop, your phone. It might make one error in 100 quadrillion operations. It's unbelievably reliable. You don't even think about it. The absolute best quantum computers we have today, they make an error about once every 1,000 operations. You just can't build anything useful on a foundation that shaky.
And the main villain in this whole story has a name. It's called decoherence. Those amazing quantum states, the superposition, the entanglement, they are unbelievably fragile. The tiniest vibration, a bit of heat, a stray magnetic field, anything can make it all collapse and destroy your calculation. The quantum state just dissolves back into the normal world. It's a constant, relentless battle to protect these qubits from the outside world. Because of this constant war with errors and decoherence, the numbers are just staggering. Right now, the best estimates say that to create one single, stable, useful qubit, what they call a logical qubit, you need to bundle together about 1,000 of these fragile, noisy physical qubits just for error correction. So you want a truly useful computer with, say, a few thousand logical qubits? You're going to need a machine with millions of physical ones. We are nowhere close to that.
To really get a sense of this challenge, there's actually a fantastic analogy from a totally different field that has also been promising to change the world for decades: nuclear fusion. Think about it. For more than 70 years, we've been working on fusion. The promise? Limitless clean energy. The theory is perfect, but the reality is that controlling that super hot plasma, keeping it stable, is one of the hardest engineering problems humans have ever faced. It's the exact same story for quantum computing. The theory promises limitless computation. The reality is that keeping the qubits coherent and stable is an equally massive, fundamental, and so far unsolved problem.
So, does all of this mean it's hopeless? That it's all just a dream? No, not at all. But it does mean we probably need to adjust our expectations and look at what a more realistic future for quantum computing actually looks like.
So the future probably isn't you getting a new QBook to replace your laptop. Instead, you should think of quantum computers as highly specialized tools. Kind of like how your computer has a GPU, a graphics processing unit, just to handle intense video games or video editing, a supercomputer in a lab might have a QPU, a quantum processing unit, to work on very specific, very hard problems, while the classical computer does all the heavy lifting.
And look, progress is happening. It's real. We've gone from just 2 qubits back in 1998 to systems that have hundreds of them today. Now, this isn't some crazy exponential explosion, but it is steady, difficult, hard-won progress. This is a marathon, not a sprint, and we're still in the very, very early miles.
So this brings us all the way back to that big question. Will it be a revolution or a highly specialized tool? And the answer is probably both. No, it's not going to be a revolution that changes your daily life anytime soon. But for certain scientists, for specific industries, it absolutely could be a revolutionary tool that unlocks discoveries we can't even imagine yet. The hype is way ahead of the reality, for sure, but the quantum journey is still one of the most exciting stories in all of science.